All right, today what we're going to be talking about is independent and dependent probability. We've worked a lot with the independent probability, so we're just going to quickly go over that again, but then we're going to dive into the dependent probability and how that differs from the independent. All right, so an example of an independent probability is if a teacher calls on a student by drawing a stick. After the student has answered the question, their name goes back in the cup with the rest of the students. Okay, so you're putting something back. The difference with dependent probability is if the teacher calls on a student by drawing a stick. After the student has answered the question, their name stays out of the cup until everyone else has been called on. So they are not replacing it. Okay, so that's the major difference. So when you're putting something back, or not changing the sample size, it's independent. When you are keeping something out and you are changing the sample size, that's dependent. Okay, so here's just some really good buzzwords to remember when you're working with both of these. So independent, if you pick something, then you return it. Dependent, if you pick something and keep it out. If the denominator stays the same each time, and if the denominator decreases each time, okay? So that's a big difference. That will definitely throw off your probabilities, okay? So the item has the same probability of being picked each time, and an item has a better probability of being picked each time because things are being taken away, okay? All right, so some of the keywords that you'll hear in independent probability is replaced, returned, put back. This is keep it, do not return for dependent. Okay. There can be multiple picks as long as one item is picked at a time with independent. There can be multiple picked as long as one item is picked at a time. These are the same, okay, for both of them. You just have to remember you can't choose like a handful, okay? All right, so here's just some great uh, situations that you might see while working with these. So I'm just going to go through and we're going to figure out which one's independent and which one's dependent. So the first one says a jar contains 6 blue, 3 red, 5 green, and 2 yellow candies. Um, Once a candy is drawn, it is not replaced. Find the probability of getting 2 greens. Now, there should be something very specific about this that you notice right away. It says not replaced. When something's not being replaced, it becomes dependent. Okay? A card is drawn from a deck of 8 cards. The card is replaced and a second card is drawn. Find the probability of getting a B and an F. Well, since it is being replaced, it becomes independent. Okay? So same thing with this one. It says, well, the jar contains blah, 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 blah. Once candy is drawn and is returned to the jar, it is an independent. And then you should see that this one says the card is not replaced, so it's dependent. All right, so how do we solve these? What's the difference here? So with the, we'll do the independent first, okay? The independent first. So I have this situation right here. A jar contains 6 blue, 3 red, 5 green, and 2 yellow. Once the candy is drawn and is returned to the jar, find the probability of getting a green, then a blue. So in order to solve this, we need to figure out our sample size. How many candies do we have in all? Well, 6 plus 3 plus 5 plus 2 is 16. So that's how many candies I have in all. And the probability of getting a green would be 5 out of 16. And then because my sample size isn't changing at all, a blue would be 6 out of 16. So in order to solve that probability, you just multiply, same, not quite sure what happened here, but it would be 5 out of 16 for the green, 6 out of 16 for the blue, and so it'd actually be 30, 256. Okay, so that's the probability of getting those two together. You just multiply them. All right, so the same thing with the dependent, okay, but here's the difference. Because it is not replaced, my probability of getting a green the first time is 5/16, but my probability of getting a green a second time, my sample space uh, changes. So 16 now becomes 15 because I don't have that original green candy. So it then becomes 5/15. Okay, so then we multiply those two together, and it's 25 out of 240. Okay. All right. So if you want some additional practice with this, here's a great activity to do. You're just using these as your sample space and using and then you're doing all of these. Now, when you see a problem, it will always look like this. It'll say the probability, it'll say P parentheses, blah, 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 if replaced. Okay, so that means the probability of choosing two red candies if I put the candies back. This one is the probability of getting a red candy, then a green candy if I don't put the candies back. Okay, pretty self-explanatory. Come in with any questions that you may have about independent or dependent probability.